This is Kids Learning Channel 1. Here, the topic CBSE Class 8, Chapter 10 Visualizing Solid Shapes. Introduction. In Class 7, you have learned about plane shapes and solid shapes. Plane shapes have two measurements like length and breadth, and therefore they are called two-dimensional shapes. Whereas a solid object has three measurements like length, breadth, height, or depth. Hence, they are called three-dimensional shapes. Also, a solid object occupies some space. Two-dimensional and three-dimensional figures can also be briefly named as 2D and 3D figures. You may recall that triangle, rectangle, circle, etc. are 2D figures, while cube, cylinders, cones, spheres, etc. are three-dimensional figures. Match the following. Square, which is two-dimensional, cone, 3D, that is three-dimensional, cylinder, three-dimensional, triangle, which is two-dimensional, cube, three-dimensional, circle, two-dimensional, cuboid, three-dimensional, sphere, three-dimensional. Note that all the above shapes are single. However, in our practical life, many a times we come across combinations of different shapes. For example, look at the following objects. A tin, ice cream. See a tent here, a cone surmounted on a cylinder. A tin, a cylinder, a cylindrical shell, which is a tin is a cylindrical shell. A cone surmounted by a hemisphere. A photo frame, a rectangular path. See, it's a photo frame. Its shape is a rectangular path. A ball, a hemispherical shell. Tomb on a pillar, cylinder surmounted by a hemisphere. Match the following objects with their shapes. Here in the left side, on the left side we can see pictures, and on the right side shapes. Right side shape is given, and you should match this with the match each other. Now match the picture. Look at the picture. An agricultural field. What is this? Answer here. Now matching with here. What is this? A triangular field adjoining a square field. See, look at this agricultural field. A triangular field adjoining. See, adjoining a square field. Here at the bottom, a square, and on top a triangular field adjoining a square field. So now come to a groove, which is the one matching with the groove. Now a cone taken, see, this one is matching, a cone taken out of a cylinder. Now look at a toy, a hemisphere surmounted on a cone. For a circular path around a circular ground. A cross path. 5. A cross path. Now it's matching with two rectangular cross paths inside a rectangular park. Now, views of 3D shapes. You have learned that a three-dimensional object can look differently from different positions, so they can be drawn from different perspectives. For example, a given hut can have the following views. See this one. Top view. front view, side view. See, this is a hut, and it has got three views: front view, side view, and top view. Now, front view, side view, top view. Similarly, a glass can have the following views: a glass, side view, top view. Why is the top view of the glass a pair of concentric circles? Will the side view appear different if taken from some other direction? Think about this. Now, look at the different views of a brick. Top front side a brick. See the front view, side view, top view. We can also get different views of figures made by adjoining cubes. For example, front, top, side, solid made of three cubes. See, three cubes are here. Now its views are given: side view, front view, top view. Solid made of four cubes. See, front, top, and side. Top view, front view, side view. Top, front, side. Solid made of four cubes. Side view, front view, top view. Now, observe different things around you from different positions. Discuss with your friends their various views. See, these are the activities for you to observe. Around you, around your school, around your house. You may see different things and see its shapes, and identify which is 3D, which is 2D. Now, some exercise given for you. Exercise 10.1. For each of the given solid, the two views are given. Match for each solid the corresponding top and front views. The first one is done for you. See, this one, a bottle. See, look at here. Yeah, its view look like this. So these are the activities for you. See, a weight, a flask, cup and saucer, container. These are the this exercise is for you. Then next page, coming to page number 158. See, question number 2. See, 10.1. Question number 2. For each of the given solid, the three views are given. Identify for each solid the corresponding top, front, and side views. You can do that. You see, top, front, side. Now, when Almira's different views are there. As I said, top view, front view, side view. Now, a matchbox. It also see front view, top view, side view. A television. A car. You see, a car. It's various views. It's view from front, top view, side view. Now, for each given solid, identify the top view, front view, and side view. So here, this is the exercise, visual exercise for you. Now, for question number 4, draw the front view, side view, and top view of the given objects. A military tent, and a hut, a dice. See, a table, a hexagonal block, a solid. Now, mapping a space around us. You have been dealing with maps since you were in primary classes. In geography, you have been asked to locate a particular state, a particular river, a mountain, etc. on a map. In history, you might have been asked to locate a particular place where some event had occurred long back. You have traced routes of rivers, roads, railway lines, traders, and many others. How do we read maps? What can we conclude and understand while reading a map? What information does a map have and what it does not have? Is it any different from a picture? In this section, we will try to find answers to some of these questions. look at the map of a house whose picture is given alongside. Now, what can we conclude from the above illustration? When we draw a picture, we attempt to represent reality as it is seen with all its details, whereas a map depicts only the location of an object in relation to other objects. Secondly, different person can give descriptions of pictures completely different from one another depending upon the position from which they are looking at the house. But this is not true in the case of a map. The map of the house remains the same irrespective of the position of the observer. In other words, perspective is very important for drawing a picture, but it is not relevant for a map. Now look at the map figure 10.2, which has been drawn by 7-year-old Raghav as the route from his house to his school. From this map, can you tell how far is Raghav's school from his house? Would every circle in the map depict a roundabout? You see the roundabout here. Whose school is nearer to the house, Raghav's or his sister's? It's very important. It is very difficult to answer the above questions on the basis of the given map. Can you tell why? The reason is that we do not know if the distances have been drawn properly or whether the circles drawn are roundabouts or represent something else. Now, look at another map drawn by his sister, 10-year-old Meena, to show the route from her house to her school. This map is different from the earlier maps. Here, Meena has used different symbols for different landmarks. Secondly, longer line segments have been drawn for longer distances and shorter line segments have been drawn for shorter distances. She has drawn the map to a scale. Now you can answer the following questions. How far is Raghav's school from his residence? Whose school is nearer to the house, Raghav's or Meena's? Which are the important landmarks on the route? Thus, we realize that use of certain symbols and mentioning of distances has helped us read the map easily. Observe that the distances shown on the map are proportional to the actual distances on the ground. This is done by considering a proper scale. While drawing or reading a map, you must know to what scale it has to be drawn or has been drawn. That is, how much of actual distance is denoted by 1 mm or 1 cm in the map. This means if one draws a map, he or she has to decide that 1 cm of space in that map shows a certain fixed distance of say 1 km or 10 km. This scale can vary from map to map, but not within a map. For instance, look at the map of India alongside the map of Delhi.